something like this. 2 steps. Because there are 2 numbers that I don't like. I don't like this 7 and I don't like this 2 because I want an x equals. I don't want a 7 and a 2 with it. So how do I get rid of those 2 numbers? I do the same thing I did before, but I just do it twice. So if I can add or subtract, I get rid of this first. So this is the addition of 7. So I'm going to subtract 7. I need to do what now? Need to do it to both sides first, and then cancel it out. Make sure if I subtract something or add something to an equation, I do it to both sides to keep it balanced. I'm looking at that balancing point of the equal sign as my balance point. I draw a line underneath. 2x is still here. 7 take away 7 now is gone because it's 0, and I don't write 0. The equal sign is still here. 11 take away 7 is 4. I'm waiting. Okay. Now we're pretty good at 1 steps from what we saw. So just divide both sides by 2. Because I'm multiplying by 2 to undo a multiply, divide, and x then is 4 divided by 2, which is 2. So that is my example. Here was the first step, getting rid of the 7. Here's the second step, getting rid of the 2, and left with just x. Let's do another one. Okay. Next question. More difficult. 6 take away 3x is 12. I got to get rid of this 6, this 3, so I have an x on its own. If I can add or subtract anything, I will do it first. What can I add or subtract?
Minus 3x. No.
No.
6. You can subtract plus 6.
Because I'd have to multiply and divide the whole side. That means I'd have to do the divide this, this, and this. Well, remember, we're working in opposites here. So we're almost doing the opposite operations to what we did before. And that makes sense. We're trying to undo. We're trying to get to the root of the answer by undoing everything.
Because the 6 is actually a plus 6.
Yes. I subtract 6 from both sides. This is a positive 6. I subtract 6 from both sides. If there's no sign in front, it is positive. I draw a line underneath. And then I go, okay, 6 take away 6, gone. Minus 3x, still here with its minus in front. 12 take away 6, 6. Now,
How did you get minus 6?
because if it's no sign in front, what is it, positive or negative? Plus. So I could write plus. So the opposite sign is minus. The sign after it doesn't affect the number. Okay. Siri, okay? What's my next step here? I've got a negative 3x is equal to 6. Do I add 3 to both sides?
You would add and multiply. You would divide.
So it's a multiplying by what number?
3. Negative 3.
I'm multiplying by negative 3. What's the opposite to multiplying by negative 3?
Dividing by a positive 3.
No, dividing by negative 3. If I divide both sides by negative 3, because negative 3 fits into negative 3 perfectly once. Divide this side by negative 3. Negative 3 cancel. Not too bad. 6 divided by negative 3?
What? 2.
That's 2.
Negative 2.
Negative 2.
6 divided by normal 3 is 2, so 6 divided by negative 3 must be negative 2. All right, going to do one more example.
I love doing this.
Okay. X divided by 7 minus 3 is equal to 12. Right. So as I said, it's like opposite order of operations. Do any adding and subtracting I can first. Milo, if you're paying attention. Akira, you good? This way is the board. Thank you, sir. So what do I do? Yep, so I have a choice of 7 and 3 to do something with. I'm going to add 3 first if I can. Add 3 to both sides. Now it's a bit weird because this is 7, but hopefully it'll tidy itself up in a second. Minus 3 plus 3 here is the thing that cancels. X divided by 7 is still there. Equal sign still here, and 12 plus 3 is 15. Next step. So this is dividing by 7. So I multiply by 7 to undo that division of 7. So dividing by 7 and multiplying by 7 will cancel. X is left behind. 15 times 7 then is 105. Yes. So you see they're getting increased difficulty. Okay.